Hello there, I'm Mr. Mortley and I'm going to be going over feedback mechanisms, both positive and negative feedbacks. This is for Unit 1 in the EDEXCEL AS Unit, World at Risk, and feedback mechanisms relate very strongly to global warming as we're about to go through. Now first off we need to define feedback mechanisms. A feedback mechanism or mechanisms are within the climate system that act to either attenuate a negative feedback or amplify positive feedback, the response to a given force. Attenuate is the opposite to amplify. The Unit 1 book, EDEXCEL book, defines a feedback mechanism as the output of a system that acts to amplify or reduce further output. So it's a very similar definition, but they mean the same thing. Now, I'm going to start by looking at positive feedbacks. So this is the first one we're going to be looking at. Now, the way I'm going to explain this, I'm going to give an example. So, firstly we have here, imagine this is our ocean, and inside we have a big block of ice. Now, one thing we learnt is that reflective sheets of ice with high reflectivity, i.e. the albedo, which is a keyword we should know, of an ice surface is very high. So this will reflect a lot of solar radiation back into the atmosphere. This means that the more solar radiation that is reflected back into the atmosphere ultimately means global warming will not accelerate as much. However, one thing we do know is that the oceans are getting warmer as a consequence of global warming. So, if we reduce our ice sheet now, I'll put the C back in, there we go. Our ice sheet, due to global warming, is now a lot smaller. So this means that our albedo, or the reflectivity of our ice sheet, is now reduced. So only so much solar radiation will get back into the atmosphere as there are less ice sheets. However, the same solar radiation is still entering our atmosphere. However, there is a lower albedo, therefore there is less reflectivity going back into the atmosphere and more of it hitting our oceans. Therefore, our oceans will become warmer as a consequence, and the ice sheets will reduce or melt further. Now, this is another example of a positive feedback loop, which is the same as a positive feedback. As we see here, with increasing CO2 emissions, this will increase global warming. Therefore, the water in the oceans will get warmer, which will increase evaporation. And as we know, increased water vapour or water evaporation is a major greenhouse gas, and that in turn will warm the atmosphere further, which leads to more global warming, leads to more evaporation, increased water vapour, which warms the atmosphere again further, and we get in this vicious loop which will increase, or as we say, create a positive feedback leading to an increased global warming. Right. Now we've looked at the positive feedbacks, we're going to go over an example of a negative feedback, something that attenuates the climate system, the force, which is in this case climate change. So, here we go, and we have the sea. This time I'm going to leave the sea without any ice in it. Now, we know that there will be an increase in water vapour as the Earth is getting warmer. However, this will create further clouds. So this means that any solar radiation that initially was hitting the ocean is now being reflected off these clouds back into the atmosphere. This means that hardly or less solar radiation will reach the ocean beneath it, where it used to come down here and heat the ocean and go away. That isn't happening in this instance. So what we have here is a negative feedback. This will create for instance, a global cooling. So less water will be evaporated into the system, which, as we know, is a greenhouse gas, and this continuing will lead to a potential global cooling and or a negative feedback. So here is a similar diagram to the one before of a negative feedback. So very similar in the sense that let's imagine we have an increase in CO2, which could increase global warming, the effect of global warming, increasing evaporation, therefore increasing low clouds. Now, I like to ignore warms here, because I think it should say cools. I would like you to have that as cools. So we have, therefore, solar radiation not getting to the surface of the Earth due to an increase in low clouds. This means beneath it you have a cooler atmosphere, and therefore more solar radiation will not be able to penetrate through the low clouds, and in effect we have a global cooling. Now, there are many other examples that we could use for negative feedbacks or positive feedbacks. For example, one example would be the melting of Arctic permafrost due to global warming leads to the release of trapped methane gas, which leads to further global warming. So these positive, which is a positive feedback again. Now these positive and negative feedbacks can be represented in flowcharts. So my suggested activity would be to research or come up with your own positive and negative feedback mechanisms, and within a flowchart illustrate the feedback by filling in the flowchart diagram, saying the connections or illustrating the links between each one, showing that loop. Finally, if you are unsure of any of the vocabulary or terms which are used in this PowerPoint or this presentation, it would be wise to research to find out some key terms that you may be confused for or confused on. Right, this has been Mr. Mortley, and this has been Feedback Mechanisms, and I hope you're more wiser than before. Cheers.